In this video, we're going to go over the intro to Git, the source control management system. You may be on a project that's using Git or be thinking about using Git or maybe new to source control altogether. But what we're going to try to do is talk about the bare essentials that you need to know to work effectively with Git, either just locally, but probably with a team with a remote repository. So we're going to talk about the how we initialize a project from scratch, how we add changes, create commits, what the gitignore is and how we use that and why we use it, simple branching and merging, adding a remote repository to our repo so that we can share our changes with others, and what it means to work with your local branches versus your remote branches. And then finally, we'll go over how a pull request works and what that is. So let's get started. In this project, what we have here is a very simple project. You could pretend has a source directory and a couple files. Nothing special really about it. But this is, at the moment, not a Git repository. It's just a directory with some files in it on my local file system. Assuming you already have Git installed, in order to initialize a Git project, the very basic thing that you have to do is just type git init and then specify the directory. In this case, our local directory, just dot. And what that did is it created a hidden .git directory, as you can see here, in this local directory. And if we take a look at it, you can see that there is the .git directory. And if we go inside of it, or we just list the contents of the Git directory, what you'll find is there's really just a bunch of metadata that Git uses to track where things are. For now, we're not going to be concerned with this, and for the most part, you probably won't ever need to be concerned with this. But know that in order for Git to track anything, this directory has to be there. You might also notice on my command line that I have a marker here that showed up out of the blue. This is something specific to my ZSH shell. I'm using omyzsh, and with there's many themes that have Git plugins essentially to show you where you're at. This is very helpful. I would highly suggest that you install something like this with your shell, whatever shell that you're using. And what it's telling us is something that we normally have to type a command for, which is the git status. If we type the git status, what we'll find is that it will say we're on branch master, which is why we see master here. And what master is the initial default branch that Git creates. This is the trunk in other systems such as SVN. It's really just the naming convention for the truth, I guess, of the project. And from there, everything else should be some sort of branch. At least typically they are. And right now, when we've performed our Git status, we can see that there's no commits yet. We haven't done anything. All it's doing is telling us that we're on this new branch master. We haven't added anything, and it notices that there's a couple untracked files. In this case, 2 directories. So what we're going to want to do is add our very first set of code and commit. And what I want to add is the source directory. So in order to do that, all I need to do is type git add and the thing I want to add. You can type dot that for the local directory to add everything and all changes. In this case, it would add both of those directories. I don't want to do that. I don't want to add the .idea project directory for IntelliJ. And it's typically not a good idea to add those sorts of files to the repository. Is usually personalized preferences and for the most part, not something you're going to want to share or force with other developers. So for now, all I'm going to want to add is the source directory. So by adding the git source directory and then performing a status, we can see now the output is a little bit different. Now it's showing that we have 2 files, the source file 1 text and the source file 2 text, that have been what they call staged. And what that means is that we've added it, we've staged it, it's now ready to be committed. This is helpful when you have lots of different changes that you want to do piece by piece, and then perform a commit all at once, and that's what we're doing here. So in order to perform that commit, we're going to type git commit -m and specify some message, and I'm just going to type initial commit. Typically in a work environment, that's going to be prefixed with your ticketing number. There's usually some sort of ties between, whatever sort of, whether you're using Jira or some other ticket tracking system. Usually you would prefix that with whatever ticket number you're working on in a team environment to have a sort of traceability and audit trail of the changes that have been made. But here we're just going to be pretty loose with our messages and type git commit -m initial commit. Now, what we can see here is that it's telling me a few warnings, really. It's saying you're committed as you. Your name and email address were configured automatically. It's not really that important, but it is showing us how to specify differences if we want to. And it's saying that it did add those 2 files. So now if we look at a git status, we're going to see something a little different. What it's going to show now is that it's on branch master still, and there's still just the .idea project file that's untracked, and everything else seems to be fine. It knows that there's nothing to be committed, or there's no other untracked files. So what happened to the source directory? Well, it's in a new commit. So if we perform a git log, what we can see is that we have a new commit with this random UUID or git SHA hash. And then the message of what we have changed. Now the files didn't go away. They're still there, of course, but they're inside of that commit. So what's important now is that if we want to make another change, we can see what happens. So from file 1, let's say hello world. Save the file. And now let's perform a git status and see what we see. Now we can see that it realizes that I modified the file 1 file, and that's it. And if we want, we can actually look at the git diff command, and it will show us. This sometimes is not very handy if you have a lot of changes in a lot of files, but for something this simple, this can be pretty handy. You can just type git diff, and it's going to show me the difference. It's going to show me that the hello from file 1 was removed and that I added the hello world from file 1. And that's exactly what we want. So let's go ahead and add that file as well. Git add source file 1 .text. Git status. We can see that the file is staged, and now we want to commit. Give it a message. Perform a git status. And now we can see now let's perform a git log. And we can see now there's 2 commits. There's the first commit with the first set of changes, and now there's the second commit with the change that happened afterwards. And now the thing that's important here is that with Git, you could actually move back and forth between commits. We're not going to do that in this video. That's something for a future video, but what's important here to know is we track 2 changes. But this leads me into the .gitignore file. The .gitignore file is something that you're going to find in almost every Git repository, and it is a special file that is there to ensure that we as developers or people making changes to this file are not tracking or committing and sharing certain files. In this case, the .idea directory is a perfect example of that. Usually you don't want to share the IDE specific project files. Sometimes you have to, depending on the complexity of the project, but in most simple projects, we don't want to do that because these are preferences that are specific to any given developer or user that is using this project. I happen to choose IntelliJ to work with this project, and I'm going to end up with the .idea project file directory for those changes. But I don't really want to share that with somebody, especially if they're using something else like VS Code or Eclipse or anything else that you name it. They're going to end up with their own project files that I don't necessarily need to see. And so these are the sorts of things that we want to, in order to give us all flexibility to work in the editors that we want, we really don't want to add and commit these files. So that's my long ramble as to why this is a perfect example. But in order to ignore this, all we have to do is create a .git directory, .gitignore, file at the root of the project. And I did not mean to do that. But what I accidentally just did is Eclipse or IntelliJ actually added that file for me. So if we look at our git status again, we can see that what happened is on that pop-up that was presented very quickly, and I just happened to click yes to, by habit, it added that file for me. We would have seen before is, if I hadn't done that with IntelliJ, is we would have seen on the command line where it was still untracked. But since I clicked that button in IntelliJ, it on my behalf, automatically perform the add of that specific file. And so that's why we see it as being staged already. Now, I'm going to make some changes to this file, and things are going to change. So what I want to do is add the .idea directory to be ignored. So what we're going to do is add this directory to the .gitignore. And when we go back to our git and save, and when we go back to the command line here and perform another git status, what we're going to see is that the .idea directory is gone because it realizes that it shouldn't add that anymore. It should ignore it. But what we see is that we see the .gitignore file is staged and also not staged, which is odd. What that means is that it was staged was the empty file, but what I did is I added something to that file. So we're actually seeing Git tracking two states here because we haven't committed yet. We're seeing that it knows that if I were to perform a commit right now, it would commit an empty .gitignore file because I didn't add that. I didn't stage that change yet. Whereas over here is the modified .gitignore with the change. And I know that seems strange because on the local file system, there's really just one file, but Git is actually tracking the difference between what it knew was added and what hasn't been added yet. And that's something that's quite powerful with Git. And we'll get into that in future videos where we get into specifics of adding parts of files and not other parts of files, which is something very powerful we can do with Git. So now that we have these changes, what we really want to do is stage it all up and commit it. So all we have to do here at this point is continue to do another git add to the .gitignore. Perform a git status. We'll see that we have all of our changes staged up, which we can now commit. I will say git commit -m adding .gitignore. So now we perform a git status. We can see we are on branch master, nothing to commit, and on a working clean tree. Everything that we've done is up to date and added as needed. If we perform a git log, what we'll see are our 3 commits now. The initial commit, the first change to the file 1, and now me finally adding the .gitignore. So these are the essentials for just performing an add and a commit to your Git repository. Now we just happen to do all of this on the master branch, which is not really what you would be doing when working on a team. What you're going to be doing on a team, typically the master branch will be completely protected from you pushing to a remote repository for security reasons. The way we perform these changes is we want to make our own branch with our features or changes that are targeted for some bug fix or something new that we're working on. And then later what we do is we merge those branches in to master or the target branches at this point. So in order to do that, we have to create a new branch. So let's do that and see what happens. So in order to do that, all we have to do, and you have to get used to the commands. This is a git checkout -b, which means create a new branch that doesn't exist. I'm going to call it feature 1. And now I'm on branch feature 1. But what really happened? Well, let's look at a git log and see where we're at. Now, if we look at the git log, the output is a bit different. What we can see is that for this commit, which is head, this is where I'm at, this is where I'm located right now, that the branch master and feature 1 are both at this commit. That might be a little bit new or tricky, but essentially what we're seeing here is that these 2 branches and my working head that I'm on locally are all on this commit. Now, since I'm on feature 1 and I wanted to make another change, let's say this new change would be to add a new file. We're adding a new feature, and so we're just going to add file 3. I'm not going to have IntelliJ add that file for me that time, so this time I can do it all through the command line. And here's file 3. If we go to the command line, we'll perform a git status. You can see that it knows that my file 3 is untracked, so I'm going to add it. At this point, since that's the only thing that it realizes needs to be added, the idea directory is already ignored, I can now freely do a .git and add git add dot to just add all the changes that are local. In this case, it's just that one file. So if we perform a git status again, what we'll see is that it's staged, it picked up that one file and nothing else. It didn't add the .idea because it's ignored at this point. So we're good to go. Go ahead and make a commit. So we added that. Now if we perform a git log, things are going to look a little bit different. So let's clear the screen. What we can see now is that my working head is pointed at feature 1, which has this commit which added file 3. And now it's different than master. So we have diverged. So if anybody else is working on master, they do not have our changes anymore. Now, that doesn't matter so much right now because we're still just local. But what we're going to do is show how do we get this change back into master. Well, we do that via a merge. Is the most basic form is going to be via merge. The way that that works is we need to go to the target branch that we want something to merge into. So we'll perform a git checkout master. It will switch us back over to the master branch. What we'll notice now is that since I've done that, file 3 has disappeared. This is Git in action. We're watching Git now manage the file system via the commits. Since I switched back to the master branch, file 3 that only lived in feature 1 branch is gone. It's gone away. However, if I go back to feature 1, we will find that the file has showed up again. So this is something that's really powerful when you're working on features or trying to do changes, is that you can commit to the branch you're on, move to another branch freely, and then come back to your work. So let's perform the merge. We'll go back to the command line and check out master again. And what we're going to do is we're going to say git merge and then the branch name that we want to merge. Simple as that. What we can see when we do that is that it did what is known as a fast forward merge. This is because there weren't any conflicts. I added a new file. It was clean. There was nothing complicated for Git to do in terms of resolving differences. And so what we can see is it did what is known as a fast forward merge. Essentially, it just puts that new commit on top of the ones that were there. Doesn't have to do anything special. And that file is added. So now that we're on master, still on the master branch, now file 3 is there. And if we perform a git log, we'll now see that master and feature 1 are back together again because they have been merged together. So that there are no difference anymore between these branches. So that's really simple branching and merging. And everything we've done so far is just local. We've gone through initializing the repository, adding changes, adding commits, creating branches, doing a simple merge. But this is all just local to our repository. Nothing here is remote, nothing's shareable. We can't work in a team environment yet. So what we want to do is get ourselves to a remote server. Now what I've done ahead of time is I've set up a repository in GitHub, just a private repository, and it's empty right now. And so this is what you'll see in GitHub or something quite similar in any other Git product that you're using. Bitbucket or so on, is that you're just going to have an empty repository with some instructions on what to do to get set up. Now, what you'll find is it's telling us 2 different ways to do this. It's telling us if you want to create a brand new repository in the command line, this is what you need to do. Well, if you look, a lot of this is really what we just walked through. Initialized the repository, added some files, committed them, and now we're at the step where we want to add the remote. Which you'll see if you look at the second set of directions is really the one that we care about, and it just skips out all the initial stuff of initializing and creating commits because we've already done that. So what we want to do here is essentially copy and paste this command to add the remote server GitHub and name it origin. You're going to find there's really nothing special about the name origin, but what you're going to find is that by convention, almost all remotes that you work with are going to be named origin. There are exceptions to this rule, but for the most part, that's what that's going to be. It's important to know that you can add multiple remotes. This is not a topic we're going to go into today, but it is something that you do all the time when working with open source software, doing forks and pull requests. Again, not a topic we're going to get into today. We'll have a future video for that, but just know that you can add multiple remotes with multiple names, any name for that matter. So let's go ahead and take this command and copy and paste back into our project. All right, so what happened? Well, let's take a look. Let's perform a git log. The git log still looks the same. So that's not all that interesting. So what really happened? Well, all we did right now is not a whole lot. All we did is just add the fact that there is a remote server, but we didn't push anything to it. We didn't tell it anything otherwise. Technically, what happened when we did that command is it really just put something into the .git directory, the .git config file. So if we look at this file, again, you don't normally want to look at these things or need to look at these things, but it's important to know what's going on. When I added that remote origin, essentially what it did is it added this stanza right here. A new remote named origin, and here is the URL to it. That's all it did. It's pretty simple. But in order for, and if we go look back at our GitHub project and refresh it, we're going to see it looks exactly the same because we haven't performed the second part, which is actually pushing our master branch up to the origin remote. So let's do that. Now here we go. Now we have our repository both local and at the remote GitHub repository. So let's refresh. And all of a sudden we see our files. We see our source file, our source directory, our 3 files, the .gitignore, and as expected, we do not see the .idea project file. So locally, again, if we look, I have a .idea project directory, and that does not live in the remote because that was ignored via the gitignore. So those are the basics of adding a remote and pushing to the remote. But what's really happening here is you have to keep things in sync. It's important to know that your local copy of the repository can actually differ and will differ from the remote repository. This is something that's actually an advantage of Git versus other source control systems. What we now have are clones. That's why they use the term clone. We have full clones of one another. So if something happened to either my copy on my local file system, or if something catastrophic happened to the repository in GitHub, we still have another copy, another clone of this repository somewhere else that we could just easily push to another repository when needed. This is very important. It allows in some situations where bad things happen to the remote repositories to just be easily put back together. This does rely on people keeping them up to date locally, which we can look at and see how that works. So let's go to back to our command line and show how working with a local branch and remote branches work. If I perform a git branch -a, I think that's the command. Yeah, I can see all of the branches that my Git system is aware of. It shows here that I'm working on the master branch. That's my active branch denoted by the asterisks. I also have a local branch named feature1 that we worked on. And then there's the remote branch, the origin branch master, which happens to meet the one that we're on now. So if we take a look at the git log, we can see how this is reflected. As before, we saw that we had master and feature, but now you'll also see, since we've added a remote and pushed that remote, we can see that we're all of those places are tracking the same commit at the same time. Now, this is where it gets interesting and different. So if I go over to, let's create a new branch here. Let's create a new feature branch and work on things and see how this behaves. So let's go to git checkout-b. We're going to call this feature2. We're going to add a new file, feature2, feature2. And if we perform a git status, again, there's that file. Let's go ahead and add it real quick. I'm just moving along. Commit-m, adding feature2. So now, if we perform a git log, you can see I'm working on feature2. I'm ahead of the local master branch, local feature1 branch, and the remote origin master branch. But we haven't pushed this thing. If we go, it's still just local. Feature2 just lives local to my setup. If we go to GitHub and look at the branches, we can see the only branch it's aware of is master because that's the only one I pushed up. It doesn't even know about the feature1 branch that we did initially because we didn't push it up. It does know about those commits. If we look at the commits, they're all there because that was tracked into the master branch, adding file 1. But the history of feature1 does not exist in this repository because we never pushed it and it was simply merged in to master. Now locally, I am working on feature 2, so I want to push that up, and let's see how this looks. So I want to share my feature with someone else. So what I'm doing is just simply pushing that up. And what we can see is that something different happened here. Since I created a new feature branch, GitHub and other products such as Bitbucket will do the same thing. They will inform you right away, like, hey, here's a link to create a pull request. You can go ahead and click on that right there. We'll get into that in a minute. But what I want to talk about is the differences between the local and remote branches. So at the moment, I just pushed feature 2, and if we look remotely and perform a refresh, we'll find that feature 2, sure enough, is in the branch list. And if we look at the commits, we can see there is the commit, and there's the file. However, so we're all in sync, and that is really great. With feature 2, at least, we can see that I'm working on feature 2. It's the same as the remote, and the master are all the same. But if I now make another change, this is where it starts getting interesting, because you can have changes that are local to a branch but not remote. You have to push them, and this can be good if you're just working on changes and you don't want to share them quite yet. And this is typically how this is going to work in your workflow. But chances are I'm not done with feature 2 yet. I just wanted to share it, but really I wanted to add something else. Let's say feature 2 is now complete. So I'm going to add this change, and I'm going to commit this. And it did add that file. And what we're going to do now, if we look at the git log, is we're going to see that we differ. So now that we can see I've made a commit locally that does not exist remotely. And so it's important to know that you are having to manage the changes that you've done locally and then pushing them explicitly. I like to show this off because a lot of times people will use tools when they first get into Git, like a UI tool, because they are just unfamiliar, and it's the easiest way to get started. But a lot of times things will happen with your branches, local and remote, and you may not know exactly what's going on. But I'm hoping that through this that you can see that there is a way to manage, and you have to manage the local branches and the remote branches. So at this point, I've made the change that I wanted, but I haven't shared it yet. And so the important thing to remember is that just because you made the commit doesn't mean everybody else has it. I just have it locally. So what I need to do is push that explicitly. So we perform a git push in origin feature 2. So again, to break down this command, what we're doing is we're just saying I want to push to a remote named origin the branch named feature 2. And what all that does is it updates that commit. And if we look at the git log, we can see that now local and remote feature 2 are both at the same place with a commit sitting in the middle. And if we look at the project in GitHub, we can see that it also has those commits. Now, in a typical work environment, you will have created this remote branch, you will have made those changes, and now it's time to really get them. Everybody agrees that they are good and they're solid. Now it's time to share them with everyone else, or at least you feel good about the changes and you want to share them with everyone else. So this is what's called a pull request. What you're doing is you're requesting to have your changes pulled into the target branch. In our case, is going to be master. So what I want to do is create a pull request for feature 2. Now I'm just using, this is going to be a little different depending on the tool that you're using. I'm just using GitHub. I think lots of people are going to be familiar with GitHub, but if you're using proprietary third-party software, another third-party Git server such as Bitbucket or AWS Code, you are going to have a different process for creating pull requests. The UI is just different product by product, but the idea and the functionality is exactly the same. So what I'm asking here is to merge feature 2 to master branch. This doesn't actually perform the merge. And what I'm doing is I'm asking to merge. I might make some comments, and this is where you're going to want to leave comments for the team members or the people that you're asking to accept your change, that, you know, this solves, you know, problem X much better. And we create the pull request. And at this point, nothing's really changed as far as Git is concerned, as far as branches and merging. It's all exactly the same as it was. It's just now we have requested that somebody will want to merge this feature in. At this point, what this looks like is going to be different by product, but it's an ability for somebody to look at the changes, make comments, and approve this or reject it before it's actually merged into the main line. This is the opportunity to get feedback and to make corrections before you force that change onto everybody and everything. Now, once you go back to your project, you're going to find that when you switch and you perform a git checkout on master again, you're going to see that Git actually reached out to the remote repository. It was able to see that it was behind by a few commits and that you can perform the fast forward. And it's actually instructing you to perform the git pull. So what I've already done is I've performed the git pull here, and we can see that the feature 2 comes in cleanly via a fast forward merge. And if we look at the git log, we can see now that master is up to date with the remote. It does have the merge commit of pulling feature 2 in. That's what happens when we merge the pull request. Now, what you didn't see was me merging the pull request as if somebody else had done it. So we created the pull request to share, and I had went ahead and merged that on GitHub, and from there the changes had changed remotely. And so what I had done is I had pulled them locally because we were out of sync. And by pulling them remotely or locally, I can see that the changes that we were making in feature 2 are here, both the first commit and the second commit. And still, that is where my local feature 2 branch is at because it hasn't changed. But what we'll find is that master and the remote master have an additional commit, which is the merge of feature 2. Now, this is a little bit different by product. Some products will, when you merge a pull request, allow you to do a squash merge, which we won't talk about right now. That's an advanced topic that we'll talk about with changing history in Git. But what we can see here is that it merged in. It's a pretty standard merge commit of that change. And if we look, now that we're on master, sure enough, we do have feature 2 text in this branch. And that pretty much covers a general push of a local branch, creating a pull request remotely for somebody else to pulling it, and then integrating that back into your local changes. This only gets easier with more and more practice, more repetition as you just go through the motions. But just want to create this video to hopefully show that the bare essentials, there is a few commands to learn, but it's not that difficult overall to add code, create commits, and branches and merging and all of the basics with Git. So if you enjoyed this video, I encourage you to click the subscribe button, and we'll have more videos for you in the future on all sorts of topics. Thank you.